All right, let's move on to the problems dealing with 12.2 and 12.3. So in these sections, we were looking at measures of central tendency. Okay, we were looking at mean, median, and mode. Mode was 12.2. And then for 12.3, those were measures of dispersion. Those were range and standard deviation. Those were in 12.3. Okay. All right. And let's go ahead and just work through those. So for mean, I'm going to wind up adding these all up and dividing by the number that I have. I'm going to need that when I do my standard deviation calculation. So I thought I would go ahead and arrange these vertically because that helps us when we're doing our standard deviation calculation. So I'm just looking at these. Sorry, I'm about to sneeze. Ooh, okay. I'm looking at these from lowest to highest. So I'm just going to write down all the scores from lowest to highest. Okay, 17, 19, a 20, and a 23. It doesn't have to be in order, but that helps me when I'm doing my standard deviation calculations quickly. And also I needed to get median anyway. 3, 4, 5, 6, 7, 8, 9, 10, just making sure I have them all there. All right, so for the mean, I'm going to add all of these up. When I do, I get 153, and there were 10 of them. So I'm going to divide by 10, and that's going to give me the mean, and that turns out to be 15.3. So that's my mean. So the mean is 15.3. I'm going to jot that down over here. Okay. When I do the median, I need to take the middle one. This is 10 data values. So I have to count down 5 or count up 5, and there's no middle number. So I look at the 2. It just happens to be that both of the 2 in the middle were 15s. If they had not been, I would have had to add those and divide by 2. Okay, so 15 plus 15 divided by 2 is what you normally do when you have 2 middle values. But see how that just turns out to be 15, obviously. Okay, so the median would be 15. The mode would be the most frequently occurring. Okay, and so for mode, we actually have 2 that occur a repeated number of times. So we would say both 11 and 15 would be modes. Okay. All right, now range, we can go ahead and knock that one out real quick, and then we'll take the rest of the time working on our standard deviation. For range, that's just the low value subtracted from the high value. So we have them in order. We could see 23 is the highest, minus 9. That's going to be 14. So the range would be 14. All right, now let's go ahead and spend the rest of the time doing our standard deviation work. So you're going to set it up in columns, and what you know, let me write the formula over here to the side. So for standard deviation, we know what it looks like is you take your data value minus the mean. Okay, then you square that, and then you add those up, and you're going to divide by 1 less than the number of data values you have. And then once you're finished with all that, you'll take the square root. And that formula will be given to you. So you just have to know the process that it's telling you to do. On the top line of your table, I want you, the place where you have your columns, I want you to show me what you did. And then underneath there, you can just do the work. So you're going to take 9 minus 15.3. Okay, that's going to turn out to be negative 6.3. Okay, then you're going to square that. And when you do, you get 39.69. Now you don't have to show your work for every value underneath there. I'm going to assume that's what you did. Okay, so 11 minus 15.3 turns out to be negative 4.3. Notice how 9 to 11 is plus 2. I can just add 2 to negative 6.3 and get that. And then there's another 11. So I can either just do 13 minus 15.3 to get the next one, or add 2 since this is 2 more here. So that's just a little technique you could use to speed this up a little bit if you don't want to have to use your calculator every time. Then 15 minus 15.3 would be negative 0.3, or you could add 2 to 2.3 because 15 is 2 more than 13. That occurs twice. Okay, add 2 to that since 17 is 2 more than 15, or take 17 minus 15.3, and you'll wind up with a positive number now. Notice that's more than the mean. That's why it's positive. 19 turns out to correspond to 3.7. 20 is 4.7 units from the mean, and 23 is 7.7 units from the mean. Now you're going to come in and square each of those. All of these will be positive values. 4.3, negative 4.3 times itself is a positive 18.49. That'll happen twice. 2.3 turns out to be, when squared, negative 2.3 times itself, 5.29. 0.3 times itself, and that occurs twice. 1.7 would be 2.89. 3.7 squared, 13.69. 4.7, 22.09. And then 59.29 would be 7.7 squared. So now you're to the point where you're going to add all of those up, and that's going to be 180.10. Okay? That 180.10 that you did is you just did everything underneath on that top part is 180.10. You've already found the deviations from the mean, and you've squared those, and you've added them up. Now you're going to divide by one less than the data values. So 10 minus 1. Then when that's done, you're going to square root. Okay? So that's going to turn out to be the square root of 180.10 divided by 9, and that turns out to be about 4.5. Okay? That would be your standard deviation. The standard deviation, 4.5. And it basically means that it's sort of like an average of the deviations from the mean. Okay? All right, so just make sure you know how to set up the columns and show me that work, because that's going to be part of, to get full credit, you'll have to show me all that. All right, and then one more question that was actually from 12.2 and 12.3 dealt with you interpreting the meanings of those. Okay, so in this one we have companies that are selling jars of instant coffee that are supposed to be 12 ounces, but anytime you measure stuff, there's going to be some inaccuracies. It's impossible to be perfectly 12 ounces every time. So 5 jars from each company were randomly selected from various stores, and then the contents were carefully weighed, and the mean and the standard deviation values were calculated for each. Okay? And we have that information here in this chart. Question A says, which company provides more coffee in its jars? Okay? Looking at the two means is what would answer that question. See how company B, the mean of the weight of the coffee in the jars that they collected from company B turned out to be 12.292. So it's more than what the average weight turned out to be from company A. So the company B would be the answer to the first one because the mean was greater. So on average, there's more coffee in those jars. Right now, the second question says, which company fills its jars more consistently? So that means that the amount of coffee in one jar is similar to the amount of coffee in the other. I just noticed company right here, those different. All right, so the jars are filled more equally to each other, okay? So for that one, I'm noticing that the standard deviation for company A is a smaller number than the deviation for company B. That means that there's less variability in the weights of the coffee in the jars at company A. Standard deviation smaller means less variability, less deviation from the mean, okay, in those jars. So they're filled more consistently. So company A jars are filled more consistently because the standard deviation number is smaller. Okay. All right, so that's 12.2 and 12.3 information.